Hello science fans, Bill Nye here. Today we're talking about the hidden force powering our world, electrical wiring. It's the network that carries energy from where it's made to where it's used, like the veins of our technological society. Flip a switch, charge your phone, run a factory. None of it works without wiring. Wires safely guide the flow of electrons, or current, to every device and light in our lives. Imagine a day without electricity. No lights, no internet, no fridge. That's the power of wiring. From tiny headphone wires to thick neighborhood cables, these metal strands are the unsung heroes of our daily lives. They're the foundation of our electrical grid. In this crash course, we'll pull back the wall to explore different types of wiring, what they're made of, what they do, and why the right wire matters. It's not just about making things work, it's about safety. Using the wrong wire can be dangerous. So, put on your thinking caps. We're about to dive into the electrifying world of electrical wiring. Ready? Let's go. It's going to be, well, electric. What exactly is a wire? Simply put, it's a conductor, usually copper, that lets electricity flow easily. Copper is used because it's a fantastic conductor, letting electrons move quickly with little resistance. But wires aren't just bare metal. They're wrapped in insulation, plastic or rubber, that keeps us safe from shocks. This insulation is an insulator, blocking electricity from escaping. The color of the insulation is a code black or red for power, white for neutral, green or bare for ground. Color coding helps electricians make safe, correct connections. Sometimes, several insulated wires are bundled together in a cable, a multi-lane superhighway for electricity. So, wiring means the metal conductor, the insulation, and the cable that brings power and information safely to us. It's a simple, brilliant system. Next time you see a wire, remember, it's more than meets the eye. It's the backbone of our modern world. Let's see how these wires work in our homes. Onward. Let's peek inside the walls of a typical house. Residential wiring carries power from your breaker box to every light, outlet, and appliance. The most common cable is non-metallic sheathed cable, or NM cable, often called Romex. Romex bundles insulated wires and a ground wire in a plastic jacket, perfect for running through walls. In older homes or cities, you might see armored cable, or BX, with a flexible metal shell for extra protection. Metal-clad cable, or MC, is a modern armored cable with a green ground wire for added safety. For outdoor or underground wiring, we use underground feeder, or UF cable, with tough, water-resistant insulation. Each type is designed for specific jobs: inside walls, exposed areas, or the outdoors. Using the right cable keeps your home safe and powered. That's residential wiring in a nutshell. Let's see how wiring changes in bigger buildings. Offices, stores, and factories need tougher wiring for bigger electrical loads. Tray cable, or TC, is used in cable trays to organize and protect wires in large buildings. Factories use shielded twisted pair, STP, and unshielded twisted pair, UTP, cables to prevent electromagnetic interference, crucial for data and computer networks. High-temperature wire, with insulation like silicone or Teflon, survives the heat from big machines and furnaces. For moving equipment and robots, flexible cords made of fine copper strands handle constant bending. These cables have tough jackets for durability. From power to data, every wire is chosen for its job, handling heat, movement, or interference. The right wiring keeps factories running and offices connected. It's all about matching the wire to the challenge. Now, let's zoom in to the tiny wires inside our gadgets. Ready for the micro world? Inside your computer or phone, wiring gets tiny and precise. Electronic and low-voltage wires carry delicate signals, not just power. Hookup wire connects components on circuit boards. Think of it as the nervous system of your gadgets. Coaxial cable, or coax, brings TV and internet signals with layers of shielding to block interference. For blazing fast data, fiber optic cables use glass strands to send light, not electricity, immune to electrical noise and perfect for the internet backbone. Ribbon cables, flat and wide, send many signals at once inside devices, keeping things organized and efficient. Each wire is designed for its job carrying data, blocking noise or saving space. These tiny wires make our digital world possible. Next time you use a gadget, remember the hidden wiring inside. Now, let's look at specialty wiring for unique challenges. The world of wires is even bigger than you think. Let's explore. Sometimes standard wire isn't enough. Fire-resistant cables keep emergency systems running during fires in hospitals and skyscrapers. Solar wire, or PV wire, connects solar panels, built to survive decades of sun, rain, and wind. Smart homes use structured wiring bundles for data, phone, video, and security, ready for future tech. There's marine wire for boats, deep sea wire for underwater vehicles, and even space wire for spacecraft. For every challenge, fire, weather, water, or space, there's a specialty wire. Engineers design each one for a specific job. Wiring adapts to every field of technology. That's the power of innovation. Now, how do we choose the right wire? With so many wires, how do you pick the right one? It's all about balancing performance, cost, and safety. Romex is cheap and easy for walls, but not tough enough for exposed areas. Armored cables like BX or MC offer great protection, but cost more and are harder to install. Copper wire is the best conductor, strong and reliable, but expensive and heavy. Aluminum is lighter and cheaper, good for big power lines, but needs to be thicker to carry the same current. Fiber optic cables are super fast and immune to interference, but pricey and delicate. Standard UTP network cables are affordable and easy, but slower and more vulnerable to noise. Every choice is a trade-off. The right wire depends on the job, where it's used, what it carries, and what risks it faces. Good engineers and electricians weigh all these factors. That's how they keep systems safe and efficient. Choosing wisely is key. Now let's talk about why safety matters most. Safety is the most important reason to choose the right wire. Every wire has a limit. It's ampacity. Too much current, and it overheats, risking fire. Breaker boxes shut off power if wires are overloaded, preventing disaster. The right insulation matters too. Indoor wire can't handle outdoor sun or moisture. That's why we use UF cable outside, with tough waterproof jackets. Proper grounding is essential. The green or bare wire safely carries stray electricity away, tripping breakers and preventing shocks. Without grounding, a loose wire could electrify an appliance. Dangerous. Using the right size, type, and insulation keeps people and property safe. It's not just about making things work, it's about protecting lives. Every safe installation starts with the right wire. That's why electricians follow strict codes and standards. Safety is science in action. Never underestimate the power and danger of electricity. Choose wisely, stay safe. From Romex in our walls to fiber optics connecting continents, wiring is the backbone of modern life. It's more than metal. It's a carefully engineered system for moving energy and information safely. Each type, from residential to industrial to electronic, is designed for a specific job. The right choice balances performance, cost, and safety. Using the wrong wire can cause fires or failures. Every wire has a purpose. Matching it to the job is what keeps our world running. Next time you flip a switch or surf the web, remember the hidden network making it possible. Wires are the unsung heroes of technology. Understanding them is your first step into electrical engineering. Science is everywhere. Keep exploring.